Hi everyone. The next topic is about structures with pointer. We know that if any variable is a pointer, pointer can only store the address of a variable. If I declare something a pointer variable like a pointer p and comma a, now pointer how to assign address to a pointer? Pointer is equals to address of a. So always remember a pointer can only store a address, cannot store any value. In similar way, we can also assign a pointer variable for a structure. So let's practice with one example. First we need to create a one structure for a program. So how to create uh, some student structure? Their members are like into roll number, next character name of 20 character length, then followed by float float percentage of a particular student, it's a float type. So now these are the structure members and in other structure. Now we want to create a pointer variable for this structure. So now the structure can able to use anywhere in the program in any one of the functions. So now I want to first create a variable for a structure. So void main. Uh, so create a structure variable struct student. The variable is a s1. In similar way, how we are creating a pointer variable for a primitive data type integer. In similar way, we can also create a pointer variable pointer p. Now pointer p also student type. A structure variable s1 also is student type. Both are now student type. So the structure is a user defined data type. Now these two variables are created same like a normal variable declaration under a primitive data type. But here S1 comma P S1 comma pointer P are a student type. Now how to assign a address of S1? How much of memory will allocate for a S1? S1 is a dynamic memory. S1 will get a memory dynamically. So it depends upon the members of a structure. Now, see how we are assigning a pointer variable for a structure. Now, P is equal to address of S1. This is a notation to allocate a address for allocate a pointer for a S1 variable. So, what happened in the real time scenario? So, yes, see, we can see after you create a S1 variable, so the structure table occupies some memory. Memory depends upon the number of members in the particular structure. Every memory has some base address. For this structure variable, let us consider base address is a 2000. So I'm not specifically mentioning that how many bytes are there for the S1. We know that clearly can understand the memory bytes for A. For in case in this declaration, what happened? A is the integer type. Total number of bytes are 4 bytes. The base address is becoming starting byte address is becoming a base address. In similar way, S1 occupies the memory which are the memory equivalent to the total members of a particular structure. Now, whatever it is, but there we can able to find a starting byte address for this corresponding S1. Let us consider the S1 memory is a in their first member is the roll number, so 4 bytes. Second 20 bytes for the character name array, and then followed by a one more 4 for the this float. Total 28 bytes may allocate for the S1. Out of them, the first 28 byte nothing but the first byte is become a base address. Now first byte address is the 2000. Now we are allocating P is equals to address of S1 means there is a pointer variable will be created. The pointer variable store the address of this corresponding structure. So now what is the base address of this structure? 2000. Now 2000 stored in the corresponding pointer variable P. Now this P is now pointing towards the structure variable. Now this is pointing towards the structure variable. Now whatever you want to apply the changes are allocating the value, read the value, write the value, all those things we can able to do by using this pointer variable. Now just you remember that this box is a one memory. On this memory can able to access by using a variable name S1. Also we can able to access by using a pointer variable P1. Now these two variables are can able to access this memory. This memory can able to access by the these two variables. One is a pointer variable can able to access in indirect approach by using the address reference. S1 is a name of this memory, so directly we can able to access this memory. Now let us continue the code by read the values into array. Read the values into corresponding variable. Now, whenever normally to read the values in structure members, how we are writing some scanf percentile d for row to enter the roll number, comma s1 dot name we are writing s1 dot name s1 dot roll number, some roll number. So this is a basic notation we had a practice in the previous discussion. But this time, let us allocate the value to the roll number by using a pointer variable. We know that pointer variable p is the address of S1. So now we can able to write. Uh, so there are multiple notations are there. So first one is a S1 dot roll number, or else we can also give a P dot. P is a reference for this corresponding base address memory. So P1 dot roll number. Usually, what do you mean by the P? What do you mean by the P? P is the address of S1. So normally we are writing S1 address of S1. This is the notation we are writing. So instead of the address of S1, can we replace the P according to the mathematical formula replication? In similar way, address of S1 can able to replace by the P. So now we can write the P dot roll number. But actually, in a programming, while we are want to create a dynamic memory or want to use a dynamic memory like a data structure concept, we should use a one another notation format. That notation here I am writing. Yeah, same percentile d, comma address of p p hyphen greater than symbol followed by roll number. So the roll number. So these are another format to enter the values. Read the values into array. So both are acceptable. Both are acceptable. Either you can use this kind of notation format, or else you have to use this notation. This is a direct way of giving a using a pointer that you can understand very easily. Now, normally, as now before I explained that S1, the address of S1 directly can able to replace with the P. So I'm replacing that P dot roll number. So that more officially, if you want to write to process the data structures or any linked list and any kind of tree kind of data structures, we had to use this kind of notation P hyphen greater than. So this is a symbol. It seems like a arrow kind of symbol. So that usually refer the reading of value into the array. So I will elaborate explanation the differences between this kind of notation and this kind of notation and any other alternate notation. That all I will explain after the end of the program. So now I want to follow this kind of notation instead of this one. So, but you don't get any error while you are using this notation, and also while you are using this notation, you don't get any error. So now for the next one. Next one, what we want to give, we want to enter a name. For the enter a name, no, we know that first thing we need to give a address of notation. So directly you can write name. Directly you can enter the name. So because of strings, generally whenever you process a string, no need to give a address because the string is the array name itself. It provides the base address. Array name itself will provide the base address of the corresponding array. So that no need to mention that already we discussed in the string concept. So now I'm not giving the address of operator. What is the another alternate? Okay, then next let's go. What is another alternate? P dot. You can also give a P dot. So instead of that one, we're using this kind of notation. The next one is a scanf, scanf percentile f, comma, address of P test to P followed by what is the name of the variable percentage. So this is a notation to read the values into structure by using a pointer variable. So next we want to print the values. Before go to the print, how many ways we can able to write the this kind of pointer to structure notation? So let me explain here. Now normally we know that P is equals to address of S1. So after executing this statement, now P is pointing to the S1. Now we can write to access any members with respect to the address. Normally we can able to use P dot roll number. Means it is a it means like it's similar to the it is completely similar to the address of S1 dot roll number. Both are same. Both are same. So what is another alternate way? So we can also mention address of P arrow with a roll number. So these are all are similar meaning. These three all are carry similar kind of meaning. So just I want to convert it to a different color. So that this is a format. P dot roll number to read the address of S1 to read the address, and address of P hyphen greater than or arrow roll number. All these three are carry the same kind of meaning. Whenever we want to extract the value or print the value by using a pointer variable with the help of indirection operator, like it means like pointer P. So now to print the values, what we are using S1 dot roll number to print the value by using the printf roll number. So this is a notation. Uh, what is the another alternate process according to the pointer? So pointer P dot roll number is a regular notation format. Instead of the S1, instead of the direct variable name, you can use the indirection operator with the pointer variable. So this is a regular notation. We had a practice with pointer concept. Now see, uh, but in the process of data structure, we are using directly P, this symbol, and this is a compositive operator, I'll roll number. Okay, these all three carry the same kind of meaning. All these three carry the same kind of meaning. To what read the address, we should follow this kind of notation. To read the value, we have to follow this kind of notation. Okay. Now, according to that one, let's print the values. Let's print the values in this program. Any one of the notation you can able to use according to your convenience. But better we have to use this kind of notation because this notation prefer to process the data structure concepts. Now I'm printing printf percentile d address of percentile d comma print the value. To print the value directly, you can use this kind of notation. Compositive operator hyphen greater than operator followed by roll number. So roll number used to print the roll number directly. So what is another alternate approach? What is another alternate approach? Another alternate approach is printf percentile d. By using pointer itself, I want to use the indirection operator. Whenever you want to use the indirection operator, includes in a parenthesis. Includes in a parenthesis. Okay. So dot roll number. Roll number. Okay. So this is the format we should use. So here are the use the corresponding notation. So both are same. Either you can use this one or else you can use this one. Either this one. So here we should be enclosing a parenthesis. Okay. Now, similarly, which can also use it to printf percentile yes, comma p compositive operator followed by name. So which is used to print the name of the corresponding array member, structure member. Next one is percentile yes percentage. So it's a very simple program to understand how to read the values into structure member by using a pointer, how to print the values of a structure member by using pointer variable. So these are the basic things we should understand. So now, oh, let us practice one program that using a function and also using a one pointer variable, how we can able to handle the structure member and their corresponding values. I want to write a new program. So up to here I don't have any change. So now after assigning this, uh, to read the values into structure, I want to use a one more function to read the values. So that read, I am using the read function, a read function. So I'm calling a read function, but their parameter should be a pointer. For which pointer is a structure kind of pointer. So I'm using this structure kind of pointer. Now actual parameter is a pointer p. Their type is a structure. So a function, this is a function used to read the values into structure members. Okay. So obviously we are expecting a, here I want to now create a division. Now I want to write a code for read function. So what is the type of the read? Maybe type of the read is a void itself. Void. But I want to read a function. Whenever you are passing a uh, some pointer, so instead of okay, instead of this one, we can use better understanding. I want to not declaring pointer variable here. I'm just declaring a variable. Here I want to declare only a single variable s1 s1. Now I want to read call a read function. Read function parameter is a it's a reference called by reference. So I'm passing a reference. So this is a basic approach called by reference concept. So that procedure I want to follow in this example. Now to access this kind of reference, what is the variable we need? We need a one pointer variable. So the pointer variable type also should be a structure type. So uh, what is the type? Student type, student type. There is a one pointer p, pointer p. So this is a formal parameter which is able to access the address of S1, address of S1. From this function, I want to read the values. So we want to read the values from this function. Now what happened here? A point S1 is a local variable to a main function. And their address is passing as a reference, as actual parameter. It is also called as a reference to the read function. Now read function as a one parameter, formal parameter, that is a pointer parameter. Now this pointer parameter, what is how it is looks like? It is a start student student. It seems like a kind of initialization of pointer variable p1. A pointer p is equals to pointer p is equals to s1, address of s1. Seems like a address of s1. So whenever you are passing this corresponding value from here, this actual parameter, which is assigned to this corresponding pointer variable. Now this notation I'm elaborating here. This notation I'm elaborating here. After you elaborating, the actual parameter is assigning to a formal parameter. The formal parameter is a pointer. Now it seems like this format. So this is a initializing of a pointer variable with a base address of a structure. Here I want to apply, I want to read the values. Same scanf, percentile d, percentile d, a comma. So how generally we are reading the values? we are reading a value with the address of S1, but address of S1 is a local variable to main. I cannot use the S1 name in this corresponding function, but already the pointer P is pointing to the S1. This is a notation also will give a will execute this kind of format. A pointer variable store the base address of a S1. A pointer is pointer P also now referring to this memory. Now, according to this that concept, what happened here, instead of this, we can use any one of this format, above any one of the format. So I want to prefer to use this third one. So now I want to use the address of P1 dot roll number. Okay. So this is used to read the value, but I'm processing with a, sorry, I'm processing with a pointer. Now where actually the values are reflected S1 variable. Yes, for that is a difference in a normal parameter passing call by value to call by reference. Whenever you call your reference, the whatever you are apply changes from the pointer variable that automatically reflect in the S1 variable. So now something I have entered. Now roll number is 72. Now 72 will automatically update at the S1. Automatically will update. S1 get updated with your roll number value. Now the next one is, and then next one I want to give a name for the uh, a second variable. I'm processing with the read function. Actually, in the read function, we don't have a S1 variable. S1 variable is local to main function, but this is under control with presently. This S1 memory is under control with presently with pointer variable P. Some pointer by using this pointer variable, I'm accessing the members of this S1 and I'm assigning the values for them from the read function. Okay. So now when I assigning a something like a percentile yes, comma, uh, so I should use it should be it should be address of P composite operator followed by roll number. Similarly here also P whenever you are using this thing, you need to use the address of P name. Okay. Next third one name F comma P percentage. Now, by using these corresponding three statements, the three members of the successor uh, get the values. Now, the name is something like XYZ. Consider XYZ. Their percentage is 78, something like a 78. Okay. So now the where you are updating by using a pointer variable. I forgot to give your address of operator. Address of. Okay. Now what happened here? When S1 is a local variable to main function, but their members are accessed by using the pointer variable. Now in the read function, I don't declare any S1 variable, but I have a base address of S1. So in a pointer variable, from this pointer variable, I update the value set S1. So no need to return anything. Already while you are executing the read function, the values are updated at the corresponding memory. So this is the things we can able to do from pointers. So without returning anything, without using any local variable, directly we are updating by using the pointer variable in another function variable. So S1 is belongs to main function, but the values are updated, completed. Then I want to control will come back to here. Now I want to display the corresponding values. All these values. I want to call you one more function display. So which values I want to display? I want to display the S1. S1 value I want to display. So this time I am passing a direct structure variable because this image I am transferring. This image I am transferring to the display function. There I want to display the values. So here I don't want to use a pointer concept. No need to use a pointer concept. Directly I am passing this image. This image. But this image can also pass by using a pointer P because pointer P means it is a S1. Pointer P means it is a S1. So either you can pass by using the pointer P1 If you are getting confused, you can use transfer it directly S1. Both are same. Both are same. Whenever you pass S1, something like a, if I pass pointer P, pointer P. So now who will pass? So now this image only will be this image only pass, but here I have not declared the pointer variable, so I want to use the S1. If you declare any pointer variable in this in this corresponding main function, and if it is assigned for the S1, you can pass the pointer variable. Like it is a pointer like a P1. If you declare pointer P1 variable and assign the address of S1 to the P1, you can pass this parameter, the actual parameter to display function. Okay. So here I'm just I'm not declared so that I am passing the S1 variable. Now somewhere we have a display function. So display function here I am closing the main function. So here I am writing. So you don't need to return anything. Display function called. So which image you want to access? You want to access the image of a S1. S1 is a structure. So that here the former parameter also will become a structure. It will be also student type. It will be also student type. Here we should declare one more variable. The variable like a, I am declaring something like a S2. Now what happened in this function, a new variable will be created. But S2 image is become a same like a S1. So there is a one more variable. There is a one more variable S2 created. One more variable S2 created. What is the data as we are received the S2? S2 receive the complete image of a S1. We have some values from S1. These are the values from S1. Same values received to the S2. Now S2 is become. What are the values we received? Some rule number is 72. 72. Name is XYZ. And percentage is 78.0. 78.0. Same value we will receive at where at S2. So now from the S2, I want to display the values. Similarly, just we want to use a function. Some, yeah. Let us process with a pointer also. Here I want to use some pointer p1 is equals to some pointer point that, and then p2, some pointer variable some p2. Okay. Now p2 is equals to p2 is equals to it's the address of yes. If I'm processing with a one pointer variable, already you receive the data to the S1. From where? From S1 to the S1. To display these values, I'm using a one more pointer variable. A pointer variable is a P2. Now you can able to print P2 dot name. You can also print P2 dot rule number, P2 dot percentile D rule number, rule number. Next you can also print P2 dot percentage. These all those things we can able to execute. In the void display function, there is a one S2 I have created, but for that I have created a one more pointer variable P2. So if there is some base address like a 3000. Now 3000 stored at where? At P2 variable. Now P2 variable stores the address of 3000. So in such a way, now P2 variable, a pointer variable pointing to the S2 memory. So S2 so that you can able to operate with P2 variable to print all those things. So it's a very easy concept, but this kind of pointer to structure basically use it to process the data structure concept, like a construction of binary tree, construction of linked list, and sorting algorithms. For every time, we basically process with structure with pointer. Whenever you executing a normal program with structure and pointer, we don't realize all those kind of things in the real time aspects. Now we are just to execute. I think whenever you see this code, you don't see any complexity. So normally how we are operating with a normal pointer with variable, the same way we are operating. But only the thing is that we have to remember this kind of notation. Now this notation and all three are same. And these three notations are all three are same. Now how we are using in the code is very important. Okay. So you don't get any error whenever you follow either this one or this one. You don't get any error. We cannot print a S1 directly. We can print S1 members, so that always the pointer also will, it must be use the members of the corresponding section. We cannot print. Do you print any S1 directly? If I write something like a print S1, you cannot get any output. Something like I'm writing your statement, because there is a variable which is a combination of, which include a collection of members. So some printf, if I have given something like I have given a printf, some data type I mentioned, and if you try to print F1, you don't get any output. It's absolutely wrong. You cannot do it. We cannot do it. So F1 is a variable for the corresponding. It's a reference variable. A object or variable for the structure. Always you need to access members only by using the name of that variable. Similarly, whenever you start using a pointer variable for a structure, we cannot print. No, we cannot operate alone a pointer variable. We can always we should access a members of a corresponding structure. So that these are the basic notation. Okay. In the next video, we'll discuss about the nested structure.